Hello, welcome to the next edition of Learning from Home with Mrs. Beckett. Today we're going to take a look at surface area. We use surface area when we're thinking about three-dimensional shapes. So just like volume, we're going to explore the shapes in the following chart. So we're going to explore prisms, which include cubes, triangular-based prisms, and rectangular-based prisms. They are a solid formed by two polygons with two congruent parallel bases. We're also going to look at cylinders, which is a solid formed by two congruent and parallel circular bases. The word congruent means equal, so that they are exactly the same. So it's the same circle on the top and the bottom of the cylinder. A pyramid, which is a solid with a polygonal base and a triangular sides that meet at a vertex. We're going to focus on just the square-based pyramids for our work today. And a cone, which is a solid formed by one circular base and a curved surface which connects the base and the vertex. So there are some additional definitions that you might want to be aware of. The first is a face. So a face is a side or base of the shape. So when we're looking at the cube, this would be a face. So one of the squares would be a face. For a cylinder, the top would be a face, the side would be a face. So keep that in mind. The next definition that you're going to want to think about is called an edge. Now an edge is where two faces meet. It makes a straight line. So when I'm thinking about an edge, I might think about this part right here. So that's an edge. So an edge is a straight line where the faces meet. And then the next definition that you're going to want to know about is a vertex. And a vertex is where three or more faces meet. And they're going to meet at a point. So if we're looking at a vertex, this point right here would be our vertex. For a pyramid, it's the point at the top, or it could be a point at the bottom. Those are also vertices or vertexes. When we're thinking about surface area, it's important to think about what makes up that shape. So when we looked at volume, we thought about how much can an item hold. But when we're thinking about surface area, we want to deconstruct that shape a little bit and think about what pieces make up the outside of that shape. It might be helpful to think about it in terms of a net. So a net is something that if we were to deconstruct or take apart this object, that if it was made out of cardboard or paper or whatever sort of material that it would be, if we unfold that, what would it look like? And then when we're thinking about the surface area, we are thinking about all those different pieces that make up that shape. So for example, for the rectangular prism, we have 1, 2, 3, 4, 5, 6 faces that we're going to have to calculate the area for, and then we're going to add those all together to come up with the surface area of that shape. Similar with respects to the triangular base, we're going to think about what is the area of all of those faces. So the triangle bottoms and then the rectangular sides. And then we're going to think about adding those all together. For pyramids and cones, it's important to note the difference between what we call the vertical height and the slant height. So when we looked at volume, we looked at the vertical height, which was the height from the vertex of the top to the very center of the shape. So this is what we call the vertical height, or the H. So this was our right angle. The slant height is the height of the slanted pieces. So when we're looking at surface area, we're looking at that slant height. Okay, so that's the height of those individual triangles. So keep that in mind as well. So let's take a look at some examples. We're going to use the formula sheet that we were given when we explored area and perimeter and volume. So that same formula sheet has all of the formulas for surface area as well. So we're going to learn how to use those formulas, what they mean in terms of what parts of the formula represent what parts of the shape. And we're also going to see how we can use distributive property to help us with that as well. So let's start with some examples of some simpler shapes. Not to mention that they're not hard, but they're more, they're the shapes that we're going to see directly on our chart. So here we have a triangular base prism. Our triangular base prism has a vertical height of 6 feet, so that's that space right there. And then if we think about, okay, where is my triangle base? So if I'm looking at this diagram, right here is the triangle base. This 3 feet refers to this edge right there. This 5 feet refers to that edge right there. We don't know what the length of this bottom is, but we can find the length of this bottom by using Pythagorean theorem, or a squared plus b squared equals c squared. Remember that when we use Pythagorean theorem, the side across from the right angle is always your c. So we're going to, before we can calculate the surface area of this shape, we have to figure out what the hypotenuse is of this right angle triangle. We're going to use, it doesn't really quite matter which one you label A or B. Let's call 3 our A and 5 our B. So Pythagorean theorem says that A squared plus B squared equals C squared. So our A squared is 3, so 3 squared. Our B is 5, so 5 squared, and that's equal to our C squared. 3 squared is 3 times 3, which is 9. 5 squared is 5 times 5, which is 25. That's still equal to C squared. Adding 9 and 25 together, we get 34. So 34 is C squared. And then to go from C squared to C, we have to take the opposite of squaring a number, which is square rooting a number. So we're going to take the square root of 34, which ends up being approximately 5.8 feet. So now that we have the length of our hypotenuse, we have enough information now to calculate the surface area of this triangular base prism. So the surface area of a triangular base prism is B times L plus A times H plus B times H plus C times H. If we're given a triangular base prism that is not a right angle, we would need to find out the vertical height of that triangle. But this triangle is a right angle triangle, so the A side is also going to be our L. So whenever you have a right angle triangle, the two legs of the right angle are going to be your base and your height of that triangle itself. So the A in this case would be your L as well. So when I'm calculating my surface area, I can calculate 5 is my B, 5 times 3, because A is the same as the L in this one, plus 3 times 6, so that vertical height of the prism, plus 5 times 6, plus 5.8 times 6. So I'm figuring out the area of the two triangle sides. Remember that area of a triangle is base times height divided by 2, but because I have 2 of them, I don't need to divide by 2. That's where the 5 times 3 comes from. And then I think about the area of each of those 3 rectangles. So 6 times 3, 6 times 5, and 6 times 5.8. 5 times 3 is 15. 3 times 6 is 18. 5 times 6 is 30. And using my calculator, 5.8 times 6 is 34.8. The last thing that you need to do is to add these 4 dimensions together to get a value of 97.8. Include your units, which is feet squared. So area, surface area, or regular area is always square units, because we're looking at a two-dimensional shape when I unfold it. Let's take a look at another example. Here we have a cylinder. When I'm looking at the surface area of a cylinder, I know from my chart that it is 2 pi r squared plus 2 pi r h. So the 2 pi r squared are the two circular bases, and the 2 pi r h would be the area of my side, so the rectangle around the outside. My radius is 2 feet. It's given to me on my diagram. My vertical height of my prism is 3 feet. You can either use the pi button on your calculator or 3.14 for pi. You're going to substitute in what you know about your dimensions for radius and height. And then we're going to solve this using order of operations. So order of operations tells us that we need to work on the exponents first. So we have to do 2 squared. So I'm going to keep my 2 and my 3.4 out front here for now. 2 squared is 2 times 2, which is 4. And I'm just going to keep this here as well. I could multiply this together at this step, but I'm just going to show this one step with just the exponents taken care of. Now I'm going to multiply. So the next part of BEDMAS says that I can multiply the numbers together. So I'm going to multiply 2 times 3.14 times 4, and that gives me an answer of 25.12. And then I'm going to add that to 2 times 3.14 times 2 times 3. And again, just using my calculator, I get 37.68. And then the last step would be to add those together. So 25.12 plus 37.68 is 62.8, and my units are feet squared. We're going to do one more example of a simpler shape before you try some questions from the Check Your Understanding worksheet. So the next one we're going to take a look at is our square base pyramid. In this diagram, our 14s are the base of the square base pyramid, and the 15 refers to our vertical height. Now, in order to calculate the surface area of a square base pyramid, I need to know not only just the base of my square at the bottom, but I also need to know the slant height. Now, when you're not given the actual slant height, so the actual dimension of that side here, then you're going to need to calculate the slant height using Pythagorean theorem. So when we have a square-based pyramid, we want to think about what one of the faces looks like, the triangular faces. And that would be if we sort of like slice this. So if we slice it and we look at what the middle of this inside would look like, we would have a vertical height of 14, and we have, 15. Of 15, and we have a base of 14. But when I'm thinking about Pythagorean theorem, I only want just one part of this triangle. So I want just the red part of this triangle. If the whole bottom of this is 14, then half of that would be 7. And that's what I'm going to use for my Pythagorean theorem. So I'm going to use 7 as my B and 15 as my A, and I'm looking for the hypotenuse, which is C. So Pythagorean theorem says a squared plus b squared equals c squared. So 15 squared plus 7 squared equals c squared. Or 225 plus 49 equals c squared. Adding those together, I get 274. And to go from c squared to c, I need to take the square root of 274, which gives me an answer of approximately 16.6, and my units are centimeters. So now I have the slant height of my pyramid, which is 16.6. Now I can calculate the surface area of my pyramid. So I have my base, which is the square, base squared. Area of a square is length times width, or b times b. And then I have 4 triangles. So I'm calculating the area of my triangles, which is base times the slant height. And usually the triangle is divided by 2, but because I have 4 of them, it just becomes 2bs. So I'm going to substitute in my values for b and s. So I have 14 squared plus 2 times 14 times 16.6. 14 squared is 196. I can multiply my 2 times 14 times 16.6 together. That gives me 464.8. And I add those two values together to get a total surface area of 660.8, and my units are centimeters squared. Don't forget to include your units, and don't forget to put your squared after your measurements. So your centimeters, your meters, your feet, your inches, whatever it happens to be measured in. I'd like for you to take a look at the Check Your Understanding questions. So this is the same worksheet that we used when we looked at the volume of three-dimensional shapes. So we're going to focus on just part A right now. You're going to do questions 2, 3, and 4. You're just going to look at the surface area only for 3 and 4. So 3 and 4 also ask you to do the volume, but you've already done the volume in that previous volume lesson. So you just need to work on 2, 3, and 4, just looking at the surface area of those shapes. Work productively on this task. Ask for help if you need to on Teams, and check your answers on Brightspace. Those are posted there for you so you can make sure you're getting those solutions correct.